started. I think this may be quorum. Thank you all for attending. My name is Mark Kiel. I'm the Chief Science Officer and founder of Genomenon. And today I'm going to be speaking to you about variant interpretation at scale, and in particular how that informs newborn sequencing. So Genomenon and I were recently at the International Conference on Newborn Sequencing in Boston, speaking to a number of these issues, giving a short talk and participating on a panel. This platform will give me a little bit more time to expound on some of the challenges that face newborn sequencing, and particularly how Genomenon is addressing those challenges. So I've listed them out just so that those in audience can follow the narrative arc. I'm going to begin with an introduction to what newborn screening is and talk to what newborn sequencing is and what the particular challenges are that face the future of newborn sequencing. And those challenges are going to be itemized by assessing the need for genomic evidence, both sensitive and specific genomic evidence, and then talking about getting that data in the hands of practitioners, so distributing that data, as well as, and critically, how that data can inform drug discovery. So beginning at the beginning with newborn screening. Newborn screening identifies individuals at risk for having a genetic disease. Typically, these are deadly or devastating diseases, and they often have interventions. And increasingly, more and more of these interventions are being devised. It's important to point out that biochemical newborn screening is a public policy triumph. So when we talk about introducing sequencing into that capability, we're not talking about replacing newborn screening by biochemical studies. We're talking about augmenting that capability. And in particular, genome sequencing promises to broaden the number of diseases that can be screened for, to identify pre-symptomatic individuals before they manifest symptoms of disease, and to promote reproducibility or homogeneity in practice across all of these testing laboratories. Many challenges remain for full implementation of newborn sequencing in this context, from technical to ethical. And the issues that I'm going to focus on have more to do with the data and the technical aspects, and in particular, the interpretation component. We are right now in a pilot phase of assessing the validity of this approach to improving public health by screening individuals at birth with genome sequencing. And in those pilot studies, these are some of the aspects that we're assessing. The sensitivity of the approach, the ability to ensure that you're finding as many patients as possible, and balancing that with the specificity of your approach, making sure that you're not making false interpretations and leading to ethical, legal, social implications, and in particular, burdening the healthcare system and making it hard for parents to receive that information that may not be crystal clear. Other aspects include assessing the overall impact to the healthcare system from lives improved or lives saved, as well as the health economics of implementation of newborn sequencing. And a last component that is being assessed in all of these pilots is the temporal component. How quickly can we turn around this data? The newborn screening ecosystem has been around for decades and is pretty robust, and that's the gold standard against which newborn sequencing will be adjudicated. So at the ICONS conference, many luminaries were in attendance: Robert Greene, Stephen Kingsmore, Heidi Rehm. On a fireside chat on the last day of that conference, Heidi Rehm was asked what the most important barrier was to realizing this as a future state for improving healthcare, and she said unequivocally that the most important challenge is the variant interpretation challenge. If we're sequencing these individuals, we need to know what that data means and how to take action on it. And that's where Genomenon figures into this as a role in providing evidence and being information brokers. So to put a finer point on what Heidi suggested was the biggest barrier, real-time variant interpretation is not feasible for newborn sequencing, especially if we're to meet the temporal and economic goals that we've set for ourselves being compared to the gold standard of newborn sequencing. The current infrastructure that I alluded to for newborn screening is there and valid, but for newborn sequencing, at the scale that we're talking about, sequencing these individuals and handling these interpretation challenges, there are too few analysts who don't have enough time, and there's not enough coordination across labs. So we need a completely different approach to make this a viable opportunity. And in particular, newborn sequencing requires a database of every actionable genetic variant interpreted in the context of screening, which is very different than in the context of diagnosis, relying on all of the available evidence to maximize the sensitivity and the specificity, and again, interpreting those variants in the context of screening to maximize the applicability and the relevance of those determinations. So to put simplistically, all of this data needs to function as a simple lookup table if we're going to have this integrated into our ecosystem in a timely and economic way. So the solution that Genomenon is espousing and is embarking on is to curate the entire human genome. And what that means is for every disease, for every gene that causes every one of those diseases, every genetic variant that's ever been published in the scientific, clinical, medical literature or any databases, all of those references and all of those database elements expertly adjudicated according to clinical standard guidelines, including disease-specific guidelines, in the context of screening, with all of that evidence provided to the practitioners in that lookup table for their review and verification. So that's the picture that I want to paint for you of what a fully curated human genome means. And Genomenon is leading the way as the information provider in the context of newborn sequencing for this. These are a couple of the partners that we've had public disclosures of our working relationship with, but we're working with a number of groups. Many of those had assembled at the ICONS meeting, up to a dozen in countries like Australia and Europe, as well as other groups locally. The ones that I'm pointing out here are Rady Children's Institute for Genomic Medicine, as well as the CDC, with their Beginnings program and Eden program, respectively. So let me go into a little bit more depth about some of these challenges that we're facing from a technical and from a data perspective. The first I'll begin with is the sensitivity challenge. So as attendees to ASHG, you're undoubtedly aware of the hyperproliferation of this information that's necessary to inform genetic variant interpretation after sequencing coming from the empirical literature. The clinical studies, the functional studies, finding that information that has exponentiated over the past several years is paramount to ensure maximal sensitivity, that none of this evidence for any of these variants is missed. And so I'm going to make a naked assertion here to say that there's only one way that we can handle that proliferation and ensure that we have maximal sensitivity, and that's using computational intelligence approaches. Put colloquially, that's artificial intelligence or AI, but there's a precision there when we're talking about what we need to find in those sources of evidence, the references, to make it valuable and viable for genetic interpretation. So AI is necessary to ensure that nothing is missed and we have maximal sensitivity for this data. This is a schematic summary of what Genomenon has done, has been building over the past decade to ensure that the data is maximally sensitive. So I've referred to this in other venues as the order from chaos slide. The chaos is the evidence in the medical literature, the clinical studies, the functional studies across multiple different publications in disorganized, inappropriately named text. So that's the chaos. But there's valuable information in that chaos that Genomenon is able to parse with our computational indexing capability, which we call genomic language processing. So that's a play on the words natural language processing, and we say there's nothing natural about the way that we describe genomic language. So genomic language processing comprises an ability to recognize the diseases, the phenotypes, the functional and clinical keywords that are described in these studies, as well as therapies that have been tested, that have been successful or that have failed in any one of the patients with any one of these genetic sequencing variants, no matter how an author can describe them. So that, writ large, is what genomic language processing is, and Genomenon has a uniquely sensitive ability to review all of that evidence on a weekly basis, up to and including many decades of historical studies. And we synthesize and organize that data, once annotated, into genomic associations, which you can see reflected with the shape on the right. And we distribute that data, the computational maximally sensitive data with evidence predicate, in a software we call Mastermind. It's a genomic search engine intended for clinical use. It has research applications, but its primary focus and utility is for interpretation of these variants based on a sensitive assembly of all that evidence. And what Mastermind's data comprises is the 9 million full-text genomic articles, regardless of paywall status, and the 3 million accompanying supplemental data sets that mention any gene in the human genome or any genetic variant described in any one of those papers, amounting to nearly 20 million such genetic variants having already been identified, kept up to date week over week. So this software is used clinically to rapidly identify that evidence as a diagnostic support capability in clinical sequencing interpretation. And the value that it provides is in accelerating that diagnosis and ensuring that there's the utmost sensitivity of that information. It's the most comprehensive such source of genetic evidence and is used by many attendees here at ASHG. But that's where I want to start with today's talk. We have a philosophy at Genomenon that you begin with sensitivity to ensure that you're not missing anything from a computational perspective, but in order for applicability to newborn sequencing, you need to ensure that that data is right, maximally specific. And in order to do that, it would be a folly to rely on computational techniques alone. So this is a challenge that we're rising to. Accurately interpreting genetic information requires a person, in our case, 4 people. Curation by those experts is necessary to ensure those calls are not only correct, but appropriate to the circumstance in which that evidence will be used, which is to say a screening in this case. So this is a schematic summary of how Genomenon is structured, with the order from chaos on the top there, the evidence in the literature, the genomic language processing to index that evidence, the organization of that evidence into genomic associations. But the next step that we take here is with an AI curation capability that allows my team of 4 expert curators to rapidly and accurately review that data. Not just the evidence in the literature, but all of the accompanying database information that's necessary to interpret this genetic evidence for clinical purposes. In addition to that, we have a processive and precise capability of reviewing that data to ensure that the data is maximally specific. So just to really emphasize, these are people who are looking at this data, and Genomenon is endeavoring to curate the entire human genome. To date, we've curated more than 300 genes, beginning with those genes that comprise the newborn screening panels and that are applicable to newborn sequencing. We're following clinical standard guidelines. I'm exemplifying the ACMG guidelines here, the population frequency databases, the predictive scores, but critically, the information in the publications to identify the clinically significant variants and the evidence that underpins that significance, as well as those functional studies that can corroborate those clinical studies. And doing all of that in a disease-specific context, wherever new disease or gene-specific guidelines have been promulgated. So the next challenge I want to speak to is how to marry those two challenges. If you're familiar with a ROC curve or a receiver operating characteristic curve, there's a trade-off between maximal sensitivity or absolute sensitivity and maximal or absolute specificity. And striking the right balance there is a challenge for all diagnostic or sensing modalities. And it's no different here when we're talking about the complexities of genetic variant interpretation. So how do we ensure that the right balance is struck between those two considerations? This is one specific example. The variant itself doesn't matter, the disease context doesn't matter, but it's a variant in an ultra-rare disease that's deadly. It's on the newborn sequencing panels, and there's a trial for a drug that's appropriate for intervention for these patients. As I say, it's an example that illuminates some of the challenges that we're talking about in marrying the sensitivity and specificity profiles of this data. The ClinVar call for this variant is conflicted because 1 out of, I think, 4 submitters said it was a variant of uncertain significance. So the reason that it was submitted as a variant of uncertain significance may very well have to do with the clinical heterogeneity of the diseases that are caused by this gene, and this variant in particular. But that's where the curation of that data, the specificity of the data, the high-touch review of that data, and the disease and context specificity with which that data is reviewed is paramount, because this happens to be the most prevalent variant among these diseased individuals. So having it be referred to as conflicting is a significant challenge if you want this data to be produced in a lookup table. Looking this variant up in a lookup table and seeing conflicting and not having the ability in those workflows with the time demands to dig in deeper is the challenge that we're talking about. So one such example to bring to life our approach to showcasing this data is we like the trust but verify model. We organize and annotate and assess this evidence, but we present that evidence as well. So all of that evidence for each of these variants that are being curated is annotated and presented in full, as you can see here, for some clinical studies that demonstrate the segregation with disease for this variant in this disease context, as well as the functional studies with reference citations for every assertion and sentence context where the authors of each of these studies have made reference to their findings for the end user of that data to verify what we have said as curators at Genomenon. So that's not to say that there's no value, or not even to say that there's not significant value in the data in ClinVar. ClinVar is a fantastic platform to organize clinically encountered variants and to have that information promulgated into the world. It's not a standalone tool, nor was it ever intended to be, and in particular, it's lacking the evidence that I talk about to ensure that the data that you're looking at is assessed appropriately. So this is, I think, the only data slide that I have, and it's a little complicated, but bear with me. This is one of my favorite visualizations is the Venn diagram. So the literature component is on my left, and the variants that have been found in ClinVar, encountered by clinicians in clinical operations, is found on the right. And there's a healthy overlap in the middle. But there's disagreement about some of those calls, as I showcased with that one example. And the disagreement can only be refereed with evidence. We're not talking about reputation. We're not talking about first submitter. We're talking about having this be an evidence-predicated assessment exercise. So that's the first thing that I want to showcase, is that there's substantial overlap between the variant complement in ClinVar and the variant complement found in Genomenon's curation, but there's still disagreements that need to be reconciled. The other thing that I want to point out is there are variants that are only found in ClinVar, and that's going to be true no matter how long we accumulate and curate this data. Those variants that are found in clinical circumstances, de novo, private variants, newly discovered variants, maybe from a gene that's newly recognized as causing disease, there will always be a role to play in aggregating that data from the field. What I really want to point out, though, is the left side component, in that there are variants that are known, that have been published, that cause disease, that are actionable, that demand to be adjudicated, especially if we're seeking to maximize the sensitivity of these newborn sequencing platforms. And there's a substantial number of those variants. This is just one example of many. where if you look, there's a selection toward pathogenic variants if they're published. And that is not because there's heavy-handed authors putting their thumb on the scale. It's because those variants are published when they're determined to be pathogenic. In contrast, the ClinVar-only variants have a bias toward being benign, because that's the nature of ClinVar, was to crowdsource aggregation of those variants. But what I want to impart to you is that there's a benefit to having these two data sets, the published variants and the clinically encountered variants, in a holistic, complete set, as long as we're sure that we're assessing the evidence and assessing it critically and in the context of newborn sequencing. So this is a fairly busy slide, and the details are technical. But I wanted to convey that we're mindful of these additional, very detailed challenges. I'll just go through a couple of them for points of interest. Happy to have conversations with any individuals afterwards. But there's this specter of the clinically significant variant of uncertain significance. And in the context of newborn sequencing, we're going to encounter those. An example would be a de novo variant that looks for all the world to cause disease, but has not yet been encountered before, and for which there's an insufficient burden of evidence to make a pathogenic determination. So as we progress in time, more of those variants and more of that evidence for those variants will be found, and I feel like there's an asymptote toward a more complete understanding of all of the genetic variants that can cause disease. But in the meantime, there's this gap, a challenge of reconciling what a VUS may mean, especially in the context of an individual who has stigmata of the disease. It's different if you see a VUS in a healthy, normal individual with no symptoms, and that's a challenge. That's an interpretation challenge at the clinical level, and the job that we see Genomenon, the role that we see Genomenon playing here, is being that evidence broker, supplying that evidence and ensuring that those practitioners are fully armed with any of the evidence that they may need to make those assessments. But that's a significant challenge. Penetrance issues follow closely behind. If you have a variant that is demonstrably causing disease in an individual, but it's in disease that exists on a spectrum of genotype-phenotype correlations with differential penetrance, there's a challenge mostly confounding clinical workflows and what to do after this variant is identified when you don't see symptoms of that disease manifesting because of an incomplete penetrance of that variant. Lastly, and something that's high on my mind recently, would be allele phasing, where you have alleles that co-traffic with each other. If our sequencing platform doesn't recognize whether the variants are cis or trans, if the variants are both adjudicated as being pathogenic, if two of those variants are found but we don't know the phasing, it will be hard for us to determine whether there's, say, a complete loss of function for that gene unless we have that phasing. So those are just a couple of the flavors of these detailed considerations where Genomenon's philosophy is the evidence will be helpful. It may not solve all these problems, but it's certainly necessary to ensure that you're positioning yourselves to optimize your ability to solve those problems. So the last two components I want to go through, I can go through rather quickly. None of this data is valuable if it's not available. So data distribution is a significant consideration. Ensuring that information is readily available is made possible through the Mastermind Global Diagnostic Network that Genomenon has cultivated over the past decade. So all of this curated data, there's the computationally assembled data that exists in Mastermind today, all of the curated data for each of these genes and each of these diseases and each of these variants is now being reintroduced into Mastermind. So when a user searches on any one of those variants, they not only see the references, but they see the full curation and the summary information based on our interpretation according to those clinical guidelines. So this is our global network of users. There's a number of our marquee partners at the bottom that you will undoubtedly recognize, but there's a very substantial long tail of additional users across 140 countries, numbering in the tens of thousands of users. And when we're talking about making this curated data maximally valuable, that's a great distribution network of clinical users including those that we're participating in these pilots with, who will benefit from that pre-curated human genome data. The last thing I want to touch on is, and I would be remiss if I didn't bring this up, is we're not stagnant when we're talking about the actionability of these variants. And I don't want to be unmindful of the role that pharmaceutical companies, drug developers play, and the need that they have to fully understand the genetics of the diseases that they're treating, in addition to the need that they have to appreciate that though it's a rare disease, there's a way to find these patients. And there's a way to get this information available to clinical users at the point of screen positivity or diagnosis. And so Genomenon has a part of our business that partners with pharma in making this data actionable, leveraging the complete data for each of these genes and the diseases that variants in those genes cause to appreciate the patterns in disease, to design more effective trials, to understand natural history studies from a retrospective point of view. Those are all of the different ways that Genomenon provides value to optimize trial design and de-risk those trials by ensuring that the maximal number of patients can be enrolled with the optimized inclusion criteria, but also ensuring that patients who don't stand to benefit from your drug based on its precise mechanism of action are not included in your trial and not diluting the likelihood that you're going to have a positive endpoint. And so these are the value propositions that we offer to our pharma clients. A number of them are listed here, some of which are here. In particular, Catherine Nestor and I are giving a talk. I don't remember what CoLab it is, but it's on Friday, where we're going to go into much greater detail about the way that we have partnered with one such pharmaceutical company in pursuit of better identifying these patients with a rare disease, to help get information out there about the best way to diagnose the most number of those individuals and to promote awareness of that trial. So again, the disease we will talk more about on Friday. It's an ultra-rare disease that can kill patients and it's very challenging to diagnose. And there's a drug for it. There's an enzyme replacement therapy that Catherine will speak to on Friday. And the way that Genomenon, through its mastermind data and solutions, has provided support is in understanding every one of those variants and all of the evidence clinically assessed, building out a retrospective natural history study of all of those patients in all of their clinical guises, using that data to better determine disease prevalence, and making that data actionable, like distributing it across the global diagnostic network that Mastermind promotes. So I want to end on an optimistic note. I'm an entrepreneur, and I like to be future-looking and glass fully full. And so this is the CODA slide that I presented at the Icons. It's true not just of the beginnings work that we're doing with Rady and Stephen Kingsmore, but of all of the groups that we're partnered with. This is the future that I see for newborn sequencing. As more and more of this sequencing is done, more and more of this evidence will be published, more of those cases will be submitted to ClinVar, and there's a mutual reinforcing positive feedback loop so that newborn sequencing will continually improve and more of these patients' lives will be positively impacted. So with that, I'd like to thank you for your kind attention and see if we do have time for any questions. Can you flip it on? We turned it off to minimize the background. Yep, there you go.
Nice talk. I have a question for you. I just want to know when you're talking about the evidence you're talking about is from the literature, right? So how it is different, like say I have a variant and I have a very scientist who's creating the variant. So they can find the same evidence that you are finding. How do you develop any other lab?
Yep. It is the fact that they don't necessarily find that evidence because we're leveraging a computational approach, and we've done studies that indicate that upwards of 20% of the references are missing, and one of those references can be critical in promoting a VUS to a likely pathogenic variant. So that's the first thing I'd say. The second and more important thing to say is we're able to do this at scale and a priori. So we don't need to have seen that variant in clinical practice. we can go back in our database that's already assembled of every variant ever published in the human genome and just tick off the curation of each of those references for each of those variants. So that's what we're doing. That's what's necessary for newborn sequencing if we're going to hope to have this happen at scale and meeting those time requirements.
I think that's what the HGMD is also doing, right? So I'm just trying to see how you are different from
Yep.
many of ours or HGMD
Yep.
because they are also just looking at the references and providing the references.
Sure. So the question is how what I described compares with HGMD. The scale notwithstanding, that's a very significant difference, but there's other differences. HGMD typically only has one or two key references and not the totality of references. Their approach is largely manual. It doesn't have an underpinning computational approach. So when that variant is curated, to recurate it, to reassess any new information, would require recurating all of those variants, and there's no feedback loop to notify HGMD and QIAGEN that new information is available. We have that feedback loop. We're doing this at breakneck scale. I have comparative statistics about how long they've been in practice and how many variants and references they have, and we've exceeded that by orders of magnitude. So when I talk about these challenges of sensitivity and specificity and make the assertion that computational intelligence is necessary to live up to those challenges, that's exactly what is informing my response to the HGMD comparison. Every gene, every variant, disease-specific context, several genes per week is our pace, and we're just getting started.
Hi, Stephen Brenner from UC Berkeley. Mark, that was a nice presentation.
Thank you.
I agree entirely with you about the importance of really having time to preparation. And I share that vision you had at the end about having positive feedback to learn more the I want to ask you a question about something slightly outside the scope of what you discussed, but the essential information. With the study that was published in Nature Medicine, that excerpt that every single child did 4.5 years with any of the disorders screening of the disease. And we found we missed the cycle fraction.
Yep.
And part of that was with the child sanitation, but actually the biggest challenge is we did not see that variance in the disease. There were no variants. And so what do you do in this case? The biggest variant
Yep, I'll repeat the question to the best of my understanding, but say that you began by flattering me, and then you cited a recent Nature Medicine paper that talked about a significant fraction of individuals that were screen negative, but it was not an interpretive challenge, but it was a sequencing challenge. It was upstream and missing those individuals. Yep. So, yep. It's a great question. I'll reinforce my statement that the more we learn and the more we aggregate and annotate this evidence, the better we will get. But also to indicate that newborn screening biochemically has its own attendant challenges. It's wrong to presume that any diagnostic assay, gold standard or not, is not without some compromise. So there will be patients that are missed. There will be screen negative, false negative individuals. I don't know that I can speak articulately to some of those sequencing challenges, other than to say that building out this compendium a priori will help inform what you can't miss. If you're ever able to see any one of those patients with any sequencing modality, if that's ever published, we will capture that in our curation and in our comprehensive variant landscape, and we can inform the sequencing technologies to ensure that they're not missing those critical places in the genome. So there's much more to discuss. I'm not qualified to talk about the technical aspects. There are other ramifications from an interpretation perspective. We can talk about it separately later. Oh, great. Yeah, again, just to be summary here, what we're talking about now is the longitudinality of these studies. And in particular, when you're in a pilot phase for newborn sequencing, that has to be considered. How we're going to track these individuals, how we're going to know what the denominator is. If you want to do positive predictive value, you need to know what you were missing. And that requires a great deal of infrastructure. The thing that I would emphasize is that we're getting started now, and there's a lot of these considerations that have been pre-cogitated by newborn screening, and we're standing on those shoulders as we're thinking about synthesizing the newborn screening and the newborn sequencing to make a more holistic benefit for public health. Thank you so much.
Thank you. Great talk. Two questions. I'm Anders from Western environment. So can you write plant spots from bitter paper as newborn screening for sequencing, or you have to get them fresh?
So we don't have any wet lab. We don't see patients. This is all data. It's a good question. It's
how long it takes just to get the data? Can you said that it's not very fast, but is it 3 weeks or 4 weeks? How long it takes?
Yep, that's a good question. So in our engagements with pharma, if we've not yet curated that gene and all of its variants, we're talking about from start to finish a matter of weeks before we've completely curated the full complement of published evidence for all of those variants. So this is happening on an ongoing basis, gene by gene, week over week. And as I said, we're at about 300 genes now, and we have a target to complete the entire newborn sequencing panels, and then turn our attention to the ACMG 73, and then hereditary cancer genes, and then other diseases that are genetic of adulthood and beyond, until we've curated the entire human genome.
In your case, is curated full genome sequencing.
It's a great question. So the input to that curation process is all of the previously published variants over all of time. So that's our input. That's our starting to-do list.
But the newborn sequence itself, do you need files of this?
So that is not where we traffic. We push the data. There's infrastructure, there's component parts, there's other partners that handle that. Typically, it would require a BAM file or a VCF file. We are data brokers. Thank you. Sure. Yeah.
I was thinking that for the variants that was just in the literature, is it because the answer actually is linked to ClinVar but was rejected from ClinVar? And if that's the case, maybe we should have like low confidence for those variants that was acknowledged recently. And do you know what's the percentage of the cases, variants like this, and how do you deal with this problem?
Yeah, it's a good question. So the question was about the literature-only variants and whether they might be rejected from ClinVar, and there's that selection bias. I have no evidence for that to be true. It doesn't stand to reason, especially because ClinVar is fairly permissive, accepts all these variants, and their approach is to rank them or score them based on submitter status and evidence clarification. The last thing I would say, though, is in all of this, we're not pushing data that we haven't reviewed. So I want to really emphasize that my team of curators will look at and read every one of these reference citations. And if the data is poor, the evidence is lacking, though it's published, that's going to be the determination. So there's a higher level of rigor in our assessment, though we're able to do this at unprecedented speed. Thank you. Thank you all for your kind attention. I'm happy to take questions afterwards. So the question is when ClinGen's variant interpretation catches up. So I don't know that there's ever going to be a crossing over point. I've likened the role of ClinGen and the role of Genomenon in trying to meet this shared goal to the public sector and private sector arms of the Genome Project. There's a role to play for both. We have the speed and the scale and can create that scaffold. They have the finesse and the expertise, and they're very meticulous, and they can mutually inform each other and reinforce each other. I don't feel like there's any point at which there will be a saturation in the near future, especially when ClinGen's curation for these genes happens by committee over years. And we're talking about having this happen week over week. It's a great question, though. Yep, good. Sure. Great. Yeah, so it's not an immediate focus. However, we don't discriminate the variants that we identify. So it's very comprehensive from a computational perspective, what we're identifying. I would say it's a beachhead. The first diseases that we're tackling are the demonstrably genetic, highly penetrant, 100% genotype-phenotype correlations that are part of the newborn sequencing panels. The next will be other diseases that fit that bill. And then following that will be the polygenic risk scores, because they're not as applicable in clinical circumstances. The evidence is much more subjective, but our data exists for that, and we have the ability to curate that information if there's interest from partners or research colleagues like you. Yep. We take them into consideration when we curate, and we integrate them in the data that we produce for pharma when it's requested. So we definitely look at that data in our curation. We don't display it, but it's being considered in our curation process. But when we're aligning with pharma in delivering these comprehensive data sets, it becomes a part of that data delivery. Yeah, so it's a good question. We're not trying to separate sheep and goats or saying better or worse. We're trying to organize and annotate the evidence and let the evidence decide. So there's a role, just like I said on this slide, there's a role to play for variants that are encountered clinically, even if there's no reference citations. There's a role to play for variants that have only been identified in functional studies that aren't yet published. Our job here is to aggregate that data, annotate it, and present that information, and let the clinical user, let the workflows decide after that data has been comprehensively organized and annotated. Yep. That's true. Yes, so there's Genomenon's philosophy is to have a strong evidence predicate. What you're talking about, though, is getting to that asymptote. It gets fuzzy when you have a significant burden of that evidence, and you can start to make predictions. We're not there yet in clinical medicine. We may be there in research, and that's an exciting opportunity. We're not doing that now with our computational capability, but it's a great substrate for turning attention to machine learning applications on that data. We can talk about that if you've got some research interests there. Yep. Let's just have a conversation here. I don't know if there's somebody next coming up. But thank you all for attending.